Okay, in this problem I need to solve the quadratic equation. And first of all, I just want to point a couple of things out to you. This is certainly an equation because of this equal sign right here. And even though the prefix or the word quadratic might make you think of the number 4, it actually has to do with this largest exponent being a 2. So in an equation, if the largest exponent is a 2 and it's got an equal sign, you have a quadratic equation. So we can solve this thing in several different ways. The fastest way is to factor. That's the fastest way. So let's actually try that first real quick. What I'm going to do is I'm going to take this 2 right here and I'm going to bring it over from the right hand side over to the left hand side. So if you change sides, you change signs, it's now a -2 on the left hand side, which means we have nothing remaining. We have a 0 remaining on the right hand side. Okay, so if I try to factor this real quickly here, if I try to factor this left hand side, I see a minus sign right here at the very end, which means my signs have to be different, right? The only way to split up 5x squared is 5x and x. The only way to split up 2 is to do 2 and 1. Maybe let's put the 2 here and put the 1 there. Now, if I factored correctly, right? If I factored correctly, I hope you see I can get 2 answers out of this pretty quickly here. Right? I'm technically setting each of these parentheses here equal to 0. This one here and this one technically set equal to 0 since it is an equation. And so I would get 2 answers of +2, and I'd get, let's see, another answer over here of -1/5. Hope you see how I can do that, but that's up to you to figure out on your own. But that's not really what I'm after. What I'm simply after is, did I even factor correctly? Maybe I didn't even factor correctly at all, so we should probably check that first. In other words, if you were to FOIL these 2 parentheses that I have here now, would I, okay, this erasing is taking way too long, would I get back to the trinomial that I have on the left-hand side of my equation? Well, let's go check and see if that works. I'm not going to do the whole full-out FOIL. I'm actually just going to try the inners and the outers here. Okay, so the inners, let's see, 1 times x would give me just an x, and 5x times -2 would give me a -10x, and if you add those up, you see that we would get a -9x. Man, that's not what I wanted. I wanted a +6x. So I hope you see, and I'm not going to bother doing this anymore. Look, factoring just isn't going to work. Okay, it's just not going to work at all. So let me get rid of all of this stuff here. And one method that always works, no matter what we try to do, is called the quadratic formula. Right? Quadratic formula always works. And so you're going to have to memorize that thing. It is, let's see if we can get it up over here. Quadratic formula is -b plus or minus the square root b squared minus 4ac. And as I'm writing this here, it reminds me, do a search on YouTube for Quadratic Formula song. A bunch of songs will come up. Maybe one of them or 2 of them will catch your fancy, and that's a good way to learn a formula, is to commit it to song. Okay, so we've got our quadratic formula over here, and I need to pick off the players A, B, and C because that's what we need inside of this formula. So let's go find out what A, B, and C are. I hope you see that A is simply just the coefficient of our squared term. B, let's see, B over here is just this +6, this +6, and C is a -2. If any of these things were missing, that would just be at 0. By the way, A cannot be 0. Think about that. Wouldn't be quadratic. Alright, we've got all the players now. Let's plug them into our formula. And I read this part of the formula here, the very first thing, as give me the opposite of B. Since my B is a 6, I want the opposite of that, which is -6. Okay? If my B was -6, then I would put +6 to begin with. Alright, so first thing is, give me the opposite of B, which is -6 plus or minus the square root of, alright, now give me b squared, that's b times itself, or 6 times 6 is 36, minus 4 times a couple of numbers. What are those numbers? Well, those numbers are a and c. A is 5 in this case, and c is a -2. All over, that fraction bar goes all the way across, okay? Not just underneath the radical stuff, but all the way across, all over 2 times my a, and my a is a 5. Okay, so I'm going to take this and bit by bit, and simplify it down as much as I can. I hope you see and agree that, look, this 2 times 5 on the bottom, that's simply just a 10, right? We can do that right here. We'll just put a 10 down here. Okay, still have that negative 6 sitting out front. Okay, let's go work inside this square root now, right? Let's go work inside the square root, and keep in mind, if this right here is larger, right? If all of this that I put in a red box here is larger than 36, in other words, 36 minus a bigger number than itself, that would give me a negative number altogether underneath a radical. And you can't have a negative number sitting underneath a radical. Well, at least you can't in lower level math classes, because that's not real. In upper level math classes, you can handle it with imaginary numbers, but we're not going to deal with imaginary numbers now. Okay, so let me get rid of this stuff here for now. What is this number? What's the result of what I have in the red box? Well, let's see. 4 times 5 is 20. And 20 times negative 2 is negative 40. But do you see there's a negative sitting out in front of this red box here? So the negative here, the minus sign here, and the negative 40 that is sitting inside the red box becomes a positive. So I really have, I hope you see, 36 plus 40, right? So those two negatives cancel each other out. Hey, that's the number 76. Cool, so I have a 76 sitting inside that radical. Now you can look at a previous video of mine and you can see how do we simplify 76. And then maybe over here off on the side, you're going to break it down into its prime factors. You can take 76 and cut it in half, right? And get 38. That's prime. Let's see, what's half of 38? Half of 38 would be 19. That's prime. And 19 is a prime number. We can't go any further with that. So I hope you see, and you can check this out in another video of mine, that look, I have a pair of 2's underneath that radical. That's going to come out of the radical as a single 2. All right. So here's what I've gotten. I've got negative 6 plus or minus 2. Again, that's coming from, right, it's coming from those identical pair of 2's right there, which was from the 76. And then 19 is still inside the radical sign, all over 10. Now we would normally stop right there, except for one thing. Let's play around with the numbers that are outside of the radical. In other words, forget the 19 because that's inside the radical. But look, see this number right here? See that number right there? See that number right there? All of them, all 3 of these, have something in common. They're all divisible by 2, right? They're all even. So I can simplify this answer one more in just one more step. Now what I'm going to show you is really, really important in that, here, let me get rid of some stuff because I'm running out of room. But what I'm going to show you is really, really important because it only works if, right, it only works if all 3 of these things, right, the negative 6, the 2, and the 10, all 3 of these numbers that are not inside the radical are divisible by the same number. That's the only way this will work. There's a mathematical reason for behind it, but I'm not going to go there just yet. Okay, so I'm going to cut negative 6 in half. That is a negative 3. I'm going to cut 2 in half. That is a 1. My 19 is still underneath the radical. And I'm going to cut 10 in half. That is a 5. So there are my 2 answers. Negative 3 plus 1 radical 19 and negative 3 minus 1 radical 19. Now mathematicians are kind of lazy, so we don't really even need to put the 1 there. Sometimes we can just write their 2 answers just like that. Hope that helps.